If you write code in Python, then I'm willing to bet that you've made at least one of the mistakes that I'm going to show you in this video. So stick around and I'm going to show you what the mistakes are and how you can fix them. Alright, so let's dive into it here with the first mistake, which is using mutable default parameters. Now I've mentioned this in many videos, but it's still extremely common, so I want to go over it again. Now, a parameter is one of the variables that you have as the inputs to your functions or to your methods. Now, you can make an optional parameter, so something like this, where you don't need to pass it, and you can give it a default value. So in this case, something like a list, meaning if I don't pass my list, it will be equal to this empty list. However, the error here occurs when you have something that is the optional parameter value that is mutable. Mutable meaning it can be changed. So in this case, a list is mutable, something like a set is mutable, a dictionary, etc. Now I want to show you what happens when we run this example code. You would expect that we're going to get a list that contains one fruit, which is apple, and one name, which is Tim, right? Because when we append without passing the list, it should be an empty list, and then we should just get two separate lists here. However, watch when I run this code and see what the output is, and notice that we get the same list twice. So again, you can kind of look at this code and you can see what we're getting, right? We call this append item, we pass apple, we call this append item, we pass Tim, and for some reason, they're actually the exact same list. Now, the reason for that is because we have a mutable value here. So what happens the first time when we call append item is this list is already created, and we use the reference to this list to append this item, which is apple. Now, you can imagine this list is actually equal to apple, or apple's inside of it. So the next time we call append item with Tim, Tim simply gets inserted inside of this list because this is a mutable value. So this is a big mistake. It can cause a lot of bugs in your program and you never want to do this. So let me show you how we can fix this. Rather than having this mutable value being equal to something like a list, we can actually just make it equal to none. Then inside of our function, we can say if my underscore list is equal to none, then what we can do is we can say my list is equal to a new list. Now, by doing this inside of the function, we end up creating a new list every time the function is called, rather than using a reference to the same list that's created when the program is kind of initialized, if that makes sense. I'm not using the exact syntax, the exact correct terms, but I'm just trying to make you understand. So now if I run this code, you'll see that we fix the problem and we get apple and we get Tim. Okay, so make sure you don't use any mutable values inside of your default parameters for functions or methods. Otherwise, you're going to get a problem like this when you're repeatedly calling the function and not passing this default. The next mistake on my list is modifying while iterating. Now, this is specifically applying to iterable objects, so things like lists, for examples, dictionaries, sets, etc. All right, so have a look at this list right here. We have a bunch of names, users. Then what we do is we loop over these users. We check if the user starts with some letter, in this case E, and then if it does, we remove it. Now, this is very common. We do this all the time. We want to modify some kind of iterable object while we iterate over it. However, if you do this directly, so if you actually modify the thing that you're iterating over, you can get some really weird behavior. Now, at first glance, this seems like it's going to work fine. And actually, if I run this, everything's all good. We end up removing Eve, there's no problem, and this code just works properly. However, if we have certain values in our list, so for example, we have something like Ellen here, you'll notice that the code starts to misbehave. So let me run this now, and notice that Ellen actually stays in our list, even though it definitely starts with an E, and based on this code, we should have removed it. The reason why we didn't remove it is because we're modifying this list while we're iterating over it. So Python is not able to actually keep track of where we are in the list when we're changing the length of the list, which is what we're doing here by removing users. Now, this happens the same if you're adding elements to the list and pretty much if you're changing the length of it at all. And there's all kinds of other weird things that you can do intentionally or unintentionally here, but the point is you need to be very careful if you're modifying the list while you're iterating over it. Now, let me explain to you why this actually happens. Internally, Python is keeping track of the index it's on while it's iterating through our users. So imagine there's some invisible variable like index equals 0. Now the first index is 0, which references Alice. So we go through here, nothing happens. We go to index 1, which is Bob, same thing, nothing happens. 2, Charlie, 3, Dave, and then finally 4, Eve. Now at this point, we remove Eve. So when we remove Eve, the length of our list actually changes and it goes from 6 to 5. Now Python is comparing the index that it's about to go to, which is 5, to the length of the list here, and it sees, oh, my index is the same as the length. That means I must have completed iterating through the list because the last index is always going to be 1 less than the length. So it just stops and it doesn't execute this next element in the for loop. So in this case, we ended up skipping ln and we never actually even checked it in this loop. However, it doesn't just happen in this situation. For example, if I have another Bob or something here in this list, a similar thing is going to happen due to the fact that we're adjusting the length. So let's go here and change this to B, and maybe let's just make this Bellin or something, and we can go beef just so we can see what happens. And let's run this and see that we kind of get this weird example where we have one Bob, we have one Bellin, and anytime we have some kind of duplicate elements beside each other, they end up getting skipped. Okay, so a lot of weird behavior can happen here if you're modifying a list or an iterable while you're going over it. Now, before we dive in further, let me introduce you to today's sponsor, ManageEngine Site 24/7, a powerful observability platform built for modern hybrid IT environments. Whether you're monitoring on-prem infrastructure, remote offices, or cloud-native networks, Site 24/7 brings everything together into a single unified view. With support for routers, switches, firewalls, load balancers, and cloud-managed devices like Cisco Meraki, it helps you track key metrics like latency, packet loss, and bandwidth usage all in real time. And thanks to intelligent alerting, your team can proactively catch issues before they affect users. But it doesn't stop there. Site 24/7 also includes tools like Network Configuration Manager to automate config backups and ensure compliance, and NetFlow Analyzer to dive deeper into bandwidth trends and traffic patterns. So whether you're managing a few branch offices or a globally distributed hybrid network, Site 24/7 simplifies complexity and delivers actionable insights. So if you're ready to optimize your network, then click the link in the description to learn more about Site 24/7 and evaluate the product for free. The next mistake I have for you is a super simple one, but this is shadowing built-ins. Now, built-ins are reserved keywords in Python for things like functions, constructors, types, etc. Now, in this case, we've shadowed the built-in type, which is list. So list is built into Python, okay? If we use it, it's actually a constructor that can create a list for us. However, if we name something list, so if we create a variable, we say list is equal to something like 1, 2, 3, this is going to work fine. We can use this as a variable, but it ends up breaking the built-in functionality of Python's list function, constructor, type, whatever you want to call it. So if I run this, you'll see like there's no problem. We can print out list. However, if I come down here now and I try to convert something to a list using the list constructor like I might before, you see that we get an error and it says the list object is not callable. So you don't want to do this. You don't want to shadow the built-in type. And it's very common that people do this with things like list, things like dictionary, because this is built in as well, things like set, for example, and another one that a lot of people miss is ID, okay? So all these variables that are built into Python that actually have some functionality, don't use them as variable names, don't use them really anywhere inside of your code, and if you want to do something like this, name it something like my list, or I commonly go with LST, right? Or rather than dictionary, you can go with DCT or something along those lines, but always just add something to it, even like dict underscore, so that you're not shadowing the built-in name. Now, the next example to show you is one that really got me confused when I first saw this, because I was like, why the heck is that the case? But this is decimal precision inside of Python, and honestly, inside of most programming languages. Now, if you look at these examples right here, you can see that we're adding 0.1 plus 0.2. You would expect that that is going to give us 0.3. Same thing here where we have some total, we're looping 10 times, we're adding 0.1. You would expect that we're going to get 1. However, if I save this and run, you can see that we actually get these really long decimal values. Now, the reason why this happens in computer programming in general is because computers are not able to accurately represent decimal points. I'm not going to get into all of the exact details in terms of how this works, but essentially the binary that computers use is not capable of doing extremely precise decimal precision math, at least in languages like Python. So you end up getting these really weird results when you try to do things like add decimal points together, subtract them, multiply them, etc. So you have to be very careful when you're working with decimals in these languages, because if you were to do something like 0.1 plus 0.2 is equal to 0.3, this would actually return false to you. Okay, so I'm going to show you an alternative approach when you're using decimal values in Python to ensure that you get the correct results. And obviously, if you're building something like a finance program, this would be very, very important. There's actually a lot more issues that pop up due to this, but I'm just showing you the basics. You're aware that this is a thing. Okay, so let me just comment out this right here. Actually, let's bring this back here. Okay, so this is a super simple library that's built into Python called Decimal. Now, it's intended to fix the problem with precision by allowing you to add decimals and represent them as strings. So in this case, I have A and B. I've made a decimal. I said, okay, I'm going to have a value of 0.1 and 0.2, and then I can add them together, and I actually get 0.3. You also have the ability to represent things as fractions. So if you have really long decimal values that you wouldn't want to type out, for example, you can use this fraction library, again, built into Python, and you can add the fractions properly. So the next mistake is just a silly one, but I wanted to mention it because it happens all the time, and that's forgetting to close a file. So a lot of times in Python, you'll open a file. So in this case, we opened a text file. We're maybe reading from it or writing to it or something along those lines, but we forget to write the line f.close. Now this is problematic because when you leave the file open, you're exposing what's known as a memory leak, and this can cause some unintended behavior with the file, especially if other processes are modifying it, reading it, etc. So you just want to make sure that you're always closing the file after you open it, and one way to avoid this is to use something called a context manager, which handles this for you. Now this is best practice. What I'm about to show you is what you should pretty much always do when you're dealing with files. So just forget this open syntax and do this instead. So we're going to say with open, same thing, file.txt, open this in whatever mode as you want. We can say as f, and then we can do something like f dot, in this case has to be read because we're opening it in R mode, and then we can do whatever operation that we want. So when we do this, we use this with, which is known as a context manager. It will automatically handle closing the file for us, even if an error occurs inside of this with statement, and it just cleans up the file for us automatically. So you can just do any of the operations related to the file inside of this indented block and not worry about closing it, not worrying about handling an exception, and it's all good to go. So just always use with, whether you're reading, writing, appending, doesn't matter. With is just the best practice. So now we move on to the last mistake, which in my opinion is the most consequential, especially if you're looking to become a real professional software engineer. Now, this is not understanding time complexity implications of the Python code that you're writing. Now, Python is a great language because it has so many built-in tools and features that make your life easier. However, you should understand how those work on a lower level so you know when you should use them or not. That's because when we write code, every line of code that we write takes a certain amount of time to execute. We have all these different time complexities that you may have heard before if you've ever looked at data structures and algorithms, for example, something like constant time or big O of 1, which means it just takes pretty much one operation to run. Something like big O of n. This means it's linear time. So if we have a list with, for example, 100 elements, it would take approximately 100 operations in the worst case scenario in order for us to run this operation. There's a bunch of other time complexities. I'm not going to teach you time complexity in this video, but the point is all these lines of code that we write, they cost a certain amount of time. And when we write code, we want to write the most efficient code possible that costs the least amount of time. But unfortunately, in Python, there's all these little methods that you can use that end up costing a lot of time that many people are not aware of. So let me show you a few examples here so you see what I mean. Okay, so I have this list items, right? It has 3 elements, 1, 2, 3. Now, for lists specifically, and strings as well, there's a lot of these methods that you can use. So things like .insert, .delete, .remove, .find, .count. Now, these are really useful, but if you don't know what they're actually doing on the lower level, you might be surprised at how inefficient your code can be when you're using them. So when I use .insert, I'm inserting element 0 at index 0. That's what it means. So I'm inserting this at the front of my items. Now, this is fine. This will work. However, this ends up costing me what's known as big O of n time, where n is the length of the list. So essentially, if my list was 1 million elements, it would cost me approximately 1 million operations to actually make this insertion at the beginning of the list. The reason for that is I actually need to push all of the elements that are in my list over 1. So I actually have to do this. I have to create this kind of new array. So like 1, 2, 3, 0. I then need to take these elements and I need to move them one by one. So I need to move 3 here, 2 here, 1 here, and then insert 0 over here. So I had to touch every single element in my list in order to make this insertion. Now again, that's fine. You can still run this method, but you should know that behind the scenes, that's what's happening. I'm going to show you a few other examples as well, but oftentimes when you're using these methods, there's actually a better approach that would be significantly faster in order to do this same type of operation. So for example, in Python, we have something called a dec or a dequeue or whatever you want to call it. Double-ended queue is really what it stands for. Now, what we can do is we can import this double-ended queue, and this gives us what's known as constant time insertion and removal because it's a queue that's double-ended, meaning we can insert from the front and the back in constant time. So if I was going to do 10,000 insertions, for example, then it would be significantly faster for me to use this dec or double-ended queue than it would be for me to use this insert method from kind of raw Python without importing this data structure. Now, I know this is a little bit confusing, especially if you're a beginner in Python. The point is you need to know what's actually happening when you use these methods, especially once you start getting more advanced, and ask yourself, is this really the most efficient way to do this, or can I implement some kind of other data structure or approach? Let's move on to the next example so you can see now how this one works. Okay, so here's another one that is very common. Let's say I have this list and I have 1 million elements in it, and I'm looking to see if this element exists inside of my values. Now, especially if this element is going to exist near the end of my list, this little innocent looking operation right here, where I check if this thing is in this thing, actually costs me the entire length of the list. That's because I need to potentially look through every single element that's inside of here to see if this exists inside of the values. Okay, so if I were to do this many times, this would be very, very expensive because I have this massive list and I'm constantly looking through all of the values in this list to see if some element exists. Okay, now a faster way to do this, especially if you're going to be doing this more than one time using this in operation, is to convert this list into a set. Now, a set is a data structure that allows for constant time insertion, deletion, and lookup. Okay, now it costs us a bit of time to create this set. That's fine. But when we want to check if something exists inside of a set, it's practically instant. So in this case, us checking if this value exists inside of the set is approximately 1 million times faster than if we were to actually use this list. Now, obviously, that's a bit of an exaggeration. It's not exactly like that in practice, but the point is the set is significantly faster for doing a lookup. So if you're going to constantly do these types of lookup, then don't just use this in, use the set. Again, you have this really beautiful syntax in Python that looks like it works really well and it does its purpose, but it costs a lot of time. Again, this costs us linear time, where this here actually just costs us constant time, O of 1, because of the underlying data structure that we're using. Okay, let's go to the next example, example 3, which is also a very common mistake related to strings. Okay, so a string in Python is what's known as a mutable data type. That means that we can't modify it once it's created. So if we want to do something like a string concatenation, which means adding a string to another string, this actually requires us to create an entirely new string. So let me show this to you. If I have a string like hello, okay, and I have a string like exclamation point, and I want to add them together, you might think, well, it's as easy as just taking this exclamation point and just squishing it to hello. However, this actually ends up costing us the time of the first string, which we can call n, and the time of the second string, which we can call m, okay? The time complexity of this operation is O of n plus O of m. Again, if you don't know time complexity, it's fine. The point is, it's whatever the length of this string is and whatever the length of this string is, that's how much time it costs us to do this concatenation. Now, that's very expensive if we do this over and over and over again. So if we look at this example here, we have some result. What we're doing is we're looping through 10,000 numbers, and we're just adding all of the numbers with a comma into this result string. Now, this shouldn't be something that should cost us a significant amount of time to do, but based on the way that we've written it, it will cost us because we have this string concatenation, which means we're constantly doing this really expensive operation. So instead of doing that, you can actually do something like this. You can create a list, which is mutable, which now gives us a property that we didn't have before with strings, which were immutable. And rather than constantly doing a string concatenation, which is very expensive, we can just add these elements to this list, which only costs us constant time, O of 1 time. We can do this practically instantly, whereas here, this costs us the length of the left string plus the length of the right string. Okay, so we end up adding all of these elements to this list, and then we just do one operation at the very end where we turn this entire list into a big string. This code right here is going to be significantly faster than this code here, even on relatively small inputs, and that's just because of the way that we've written it and our understanding of the data structures and the operations that we're performing in Python. Now again, I don't want to get too complex here because this is a whole other video that I could make, and if you want that video, let me know in the comments down below. The point is, understand what these operations are actually doing and the amount of time that they cost to ensure that you're writing more efficient code. Alright guys, so with that said, that's going to wrap up the video. If you enjoyed, make sure to leave a like, subscribe to the channel, and I will see you in the next one.